in this talk, I will talk about visualization tools for thought. I will introduce a couple of tools that I developed. We think that we are much smarter and stronger than what we used to be in prehistory. And even just compared to 10 years ago, we think that we are able to do much more than what we used to do in the past. However, in fact, our physical abilities as well as cognitive abilities have actually mostly remained the same. And it was mainly mostly the tools that improved our strengths as well as amplified our physical abilities. And also it was digital devices like personal computers that extended our memory as well as expanded our intelligence and cognitive capabilities. And likewise, all these tools that you must be familiar with, like Adobe Photoshop and Microsoft Word and spreadsheets, these tools kind of revolutionized the way we draw, the way we write, and the way we crunch numbers. So over the past couple of years, I've been developing software tools for people to create visualizations in different contexts, especially to support these 4 different tasks, from designing data-driven graphics to writing data-driven articles. So in this talk, I will talk about each project to support each task. So let me start with designing data-driven graphics. So in order to support this kind of expressive data graphic, infographic, we developed something called data-driven guides. And one of the motivations that I had was from interviews I had with professional designers. So in order to create such infographic, they use graphic design tools like Adobe Illustrator, which you might be familiar with. And one of the problems with these tools is that they do not provide well-defined data abstraction, which means that sometimes they create this manual ruler, custom ruler they draw by themselves in order to measure the shape of the graphic based on the data, which is really time-consuming and tedious process. So our motivating question for this project was, how might we support flexible data-driven drawing in these kind of free-form graphic design tools? And our main idea was not to create a complete graph like this, but to generate guides, which are familiar to many graphic designers, so that they can draw their own shape with the help of the guide. So we implemented this idea of data-driven guides in a web-based graphic design tool, which I built from scratch. So let me briefly show you how we can create this flower chart using the tool. So you first start by loading the data set. Here I'm importing the GDP of the G5, 7 countries. You can manipulate the guide and you can draw a shape on top of the guide. And then you can repeat this shape so that you don't have to draw this shape over and over again. And here I'm importing another data set, well-being index data for a specific country. And on top of the guide, I'm drawing a flower shape. And you can simply copy and paste this flower for the rest of the stem shape. And then just change the underlying data, and that will automatically update the shape of the flower. And generating labels, we also support automatic label placement. And now you have a flower chart. It was a little bit fast, but I hope you can actually get the main idea behind this technique. Oops. And let me show you another example. In this case, the process is top-down, meaning that it's not from the data bottom-up, but you start with an existing graphic and then repurpose the graphic with the data. So here I imported the monster graphic, and I just imported the hypothetical data, and trying to repurpose this monster graphic by resizing the teeth to match the size of the guide. And generating labels. You can use this as a template, just like before. You can copy and paste it, and then change the underlying data, and that will update the size of the teeth based on the data. So you may wonder, like, who created this kind of monster graphic? So this original graphic that was based on was from famous infographic designer Nigel Holmes. You might heard of him. So in 2010, there was an interesting study. Researchers compared these two graphics, monster graphic and a standard chart, and what they found was very interesting. They found that this monster graphic is much more memorable and also equally comprehensible compared to standard chart. So I'm going to transition to a second project, Data Selfie, which was a follow-up to Data-Driven Guide, bringing the expressivity of Data-Driven Guides into a personal context to enable people to draw personalized visuals to represent their data. So probably you are familiar with some of these tools like Apple Health and Google Feed. They use automatic sensors to collect your physical activities and show the collected data using visualization. But the kinds of data is limited, so you can use a custom survey like this in order to track whatever data you want by creating your custom questionnaire. And then these tools like Reporter also visualize the data using a standard representations. One of the main issues from these tools is that they use predefined visuals, and these visualizations are system generated. And this means that the person who is collecting the data has a passive ownership of the visual representations of their own data. So our motivating question was, how might we enable people to draw, control the representation of their own data? And one of the main inspiration we got from the famous designer Giorgia Lupi. So she created this visual survey, which is called Data Portrait at the TED conference. So given this questionnaire, each participant at the conference fill out this questionnaire and they get a unique visual representing their response. However, this survey is also developed by a professional designer and professional programmer. So we wanted to generalize this idea in order to empower any individuals to create a visual vocabulary to represent their own personal data. So we augmented the survey tool like Google Forms, any other survey tool with the drawing canvas. So you can write your own questionnaire and draw a unique representation for each option, for each question. And at the end, you have a nice visual vocabulary representing the whole questionnaire. And once you fill out the questionnaire, based on the mappings, based on the response, you get a unique visual representation. So let me show you a demo. Sorry. So you create a visual survey. Here I'm writing the title of the survey, and this is writing the question and writing each option. And for each option here, the person is drawing a unique, personalized visuals representing each option in the question. And as you can see, we support a touch tablet and the stylus in order to provide a natural drawing experience. And here is drawing another visual for a different question. And you can inspect the question, the visual mappings in this layer panel. And once you fill out the questionnaire, then as I mentioned, you get a visual representing response along with the legend explaining how you read the visual. So in addition to general drawing mappings, we also support automatic drawing. So here you draw some cat shape like, and we auto-complete the cat shape using Google's AutoDraw. And you can also import emojis as well, which could be useful for people who are not familiar with drawing. And we also support automatic propagation of the shapes, so you can copy and paste the shapes across the different question options. So if you manipulate this shape and automatically updating the other shapes in the other options. And we also support automatic size encoding and the color encoding. So one main difference from data-driven guide is that the visualization creation process in the data-driven guide is more descriptive, meaning that given a data, you create a visualization in order to describe the data, existing data. On the other hand, in data selfie, you create a visualization vocabulary first, and once the data is collected, the vocabulary generates the visualization. So the process is more generative and parametric. All right, so I'm going to move on to the third project, which is about making a data stories using elements of comics for communicating dynamic network data. So data-driven guides and data selfie were useful for creating single visualizations, single pictures, which may not be enough to convey a compelling narrative. If you think about it, the most effective information delivery tool in the history of mankind is actually storytelling. So our motivating question was, how might we use these elements of storytelling in order to convey data-driven messages more effectively? And we decided to use comics, which are familiar to many people from kids to adults, and allow us to break down the complexity of data into multiple panels so that we can focus on one message per panel. Also provide a way to naturally combine with the textual elements to explain the context of the data much more effectively. So here are a couple of examples that we created using the tool Data Tune. So in this talk, I will show you a brief demo creating the example on the top right corner. So in order to create a comic, you first need to explore the data. So here I imported a data set, and we automatically detect patterns and create panels for you. You can use them if you want. You can use stylus to highlight or annotate the panel. You can create visualizations by simply bringing a data dimension from the legend panel. You can add additional dimensions to the panel to show more relationships in the panel. And you can filter the data using the time slider and use filter pan in order to extract a subgraph out of the panel. You can use label pan to reveal the labels of the countries and highlighter to highlight certain groups of nodes. We also support this interesting feature called magic pan. So if you draw a line out of the panel, we extract patterns and then create new panels for you. So once you explore the data, now you need to create an actual comic. So you start by drawing a storyboard, writing down what you want to communicate, and fill the storyboard with the panels you created earlier. You can also import the background image. Right now, we don't support geocoding, so you kind of have to manually position the nodes in their corresponding geolocations. Here, I just duplicate the panel and using label pan to reveal the country names. And in the next panel, filter the data to highlight the specific relationship between the United Kingdom and Belgium, and using a separate panel to explain the context of the relationship just before the outbreak of the World War I. And in the next panels, you show different relationships among different countries, using a highlighter to highlight the specific relationship among these three countries, Germany, Austria, and Russia. And then you can also add a freeform annotation to highlight the isolation of France against the other countries. You can also customize the representation of the node. Here we added the sketch filling to the nodes. You can customize individual node. Here I am drawing a France flag. If you're not familiar with drawing, you can also import an image, and that will do the same. We also support, through the Magic Pan, we also support automatic transitions between the panels. So given these two panels, if you draw a line between them, we automatically interpolate and fill the gap between these two, which is really essential to the comic if you think about it. readers use their imagination to fill the gap between these two panels, and which is called gutter. And manipulating this gutter is the creativity of the author of the comics. So we support manipulating this gutter using this automatic transition. So overall, data tunes support data storytelling process spanning from exploration to explanation in this unified environment with pen and touch interactions. So I'm going to move on to the last talk, which is about writing data-driven articles, which is working in progress. So I will keep it brief. This is the first time presenting this project to the public, so it's still working in progress. Yeah. So there are many different storytelling genres. One of them I presented is comic strip, but there are also other types of storytelling, data storytelling, including magazine styles, annotated charts, slideshows, films, animations, videos, and so on. One of the common thing across all these storytelling data stories is that there is a synergetic relationship between the chart and the text, meaning that charts engage readers and present an perceptually effective representation of the data. On the other hand, text provide guidance to readers and explain the context of the data. So they really create a symbiosis relationship. In this project, we are focusing on writing a data-driven document. So we are focusing on magazine style, but the idea behind this project can generalize to other types of storytelling genres. So here is a motivation example. So when you read a data-driven article, like in news media, like New York Times and Wall Street journals, you normally come across a text snippet as well as a corresponding chart. And normally you need to move your eyes back and forth between the text and the chart in order to find references between them. For example, here they mention some country names. So you may want to go back to the chart and find where these countries are located, and so on. So this kind of create like a frustrating experience for the readers. One way to overcome, so our motivating question for this project was that how might we support in establishing references between the text and the chart? So one idea is that basically creating more explicit links between the text and the chart so that you don't need to look for cues where these texts correspond to which part of the chart. So with this kind of visual cue, we can easily overcome this cognitive difficulty called split attention effect. So right now we support, our prototype support 3 different interactions. So we use natural language processing in order to analyze the text while you are writing the text, and then detect some of the entities if they are relevant to the chart, and then highlight them using underlines, using dashed line. You can also explicitly trigger the link by using S symbol and then type something like M that we automatically analyze like whether there are any matching text entities to the chart. You can also select corresponding part in the chart, and then you can manually explicitly create a link between them. So these are the 3 interactions. I will show you a very short demo. As I mentioned, this is working in progress. I apologize for in advance. So here we created a 2 chart communicating the COVID data in the United States. And here I imported the chart into the document and then start typing the text. As I mentioned, while you are typing the text, we run a natural language processing in order to see whether some of these entities, state names, matches to the entities in the chart. So as you can see, some of the entities are automatically highlighted using dashed lines. That means that they have some references to the chart. And of course, you can select portion of the text and then explicitly create a link by selecting a corresponding part in the chart. And you can accept automatically suggested links as well. So once you write the document, once you switch to the reading mode, all the references are activated on mouse hover, providing a much more fluid reading experience to the reader. So in this talk, I talk about 4 different projects supporting these 4 different tasks, spanning from designing data graphics and writing data-driven articles. So I want to conclude this talk by reminding you that tools can empower us to do things that are not possible otherwise, and especially visualizations have gone mainstream, used across different fields from science to journalism. And I think this presents exciting opportunities for us to build useful and usable tools in order to innovate how we interact with data. So with that, I'd be happy to take questions, and thank you.